Okay, I think we're running. So, yeah, good morning, everyone. I'd like to kind of talk about nature-based tourism and particularly about geotourism in the Canary Islands. And the Canary Islands are almost exclusively volcanic. And therefore, what we're really talking about today is volcano tourism. But I will mention also cultural aspects, industrial aspects, agricultural aspects, and also some biodiversity aspects at the side. So, but volcanoes, that's the kind of key theme. So what is tourism? I'm sure you have heard this. Tourism is the temporary short-term movement of people to destinations and outside places where they normally don't live and work. And there they can do activities. So, this is what this is about. People go to places like the Canaries, and here in the image is Teide volcano in Tenerife, and we'll come back to the Teide National Park a little later in the talk. And yeah, people can do all sorts of activities there, and it's very attractive. Millions of people are visiting the Canaries every year, and Teide National Park has over 4 million visitors on in average years, and Tenerife itself has between 11 and 16 million visitors per year. So this is a large number of people. So what I will talk about today is geotourism, and in particular volcano tourism. I will first of all give you an introduction to the geology of the Canary Islands after we've done some basic definition. And then I will introduce you to virtually all the islands. We will talk about Fuerteventura and Gran Canaria a little bit, about La Palma, then very briefly about Gomero, a little more about El Hierro, and then I will focus quite strongly on Lanzarote and the Timanfaya National Park, and Tenerife and the Teide National Park, the two prime national parks in the Canary Islands. So, geotourism. Well, geotourism is defined as tourism that sustains or enhances the geographical character of a place, its environment, culture, aesthetics, heritage, and the well-being of its residents. Geotourism incorporates the concept of sustainable tourism, that destinations should remain unspoiled for future generations, while allowing for ways to protect the place and its character. Geotourism also takes a principal form from its ecotourism cousin. So there is links here. And tourism revenue should ideally promote conservation. That's the idea here. So here we have all these links to culture, history, and the aspects of a certain place that come in, and the Canaries have a certain character, and many people in Europe like that. It's not just because it's warm and there's some beaches, there's also a lot of other features. And here's a little diagram, and we don't have to go into the details here, but it's nature that is, of course, linking to a lot of other things. So you as an individual have opportunities for activities, but at the same time, you have the opportunity for self-reflection, for imagination, for changing your perception and interacting with local people and also with the landscape. And of course, in this particular case, you can learn about geology and in the Canary aspect about volcanoes. So ecotourism, and again, you have heard these definitions before, I'm very, very sure. And this is about responsible travel to natural areas and to conserve the environment while interacting with the environment and the local culture and people. So here we have on the right-hand side, geotourism being in a sort of mesh, in a sort of network with cultural tourism, ecotourism, and of course, when it comes to volcanoes, there's also adventure tourism. And let's continue here. So geotourism adds to ecotourism, and it's a principal focus in ecotourism on plants and animals, while here we're looking at geological features, and in the Canaries in particular, we're looking at volcanoes. This is growing around the world quite strongly. There is an increasing number of geoparks where geology is the prime interest. And here we have people who are flocking to certain geological places because there's something special to see. So nature-based tourism in the Canaries is also linked to geoheritage, and this encompasses global, national, statewide, local features of geology at all scales. They are intrinsically important. They are important for the culture that developed in a certain place, and not just the culture, but also the agriculture, the industry, and also the traditions of a certain place. And once we can also use them for teaching, and in the Canary Islands we can learn about volcanoes quite superbly, then this kind of geoheritage aspect becomes increasingly relevant in geotourism. What's very important in geotourism is the concept of a geosite. And here I will show you a lot of geosites today, places where you can see certain things in order to understand processes, phenomena, and relationships. And geosite can be very small, it can be very big, it can be the entire volcano, it can also be something small like a certain plant that only grows on a certain type of rock in a certain place. And therefore it can be from centimeters to many kilometers. So this is the concept of the geosite, and we will look at some very small scale features as well as some big scale features. So looking at the environment in a simplified manner, usually we kind of start with this ABC concept: abiotic, biotic, and culture. And here in the geotourism concept, our main focus is on the abiotic environment. And this is the particularly interesting aspect about geotourism. It adds to existing concepts that look at biodiversity and pure cultural tourism by looking at the ground and the relationship people have developed, or the culture that developed from the geology that is present in a certain area. And the most popular form of geotourism is volcano tourism. And you might or might not be familiar, but there was this rather sad case of the White Island disaster in December last year, about a year ago now. And this was a problem in terms of volcano tourism having gone a little wrong. But you see how attractive it is. And there is a certain excitement about volcanoes, and people have this quite widely. It goes back to Darwin, and this has now been found being widely exploited. So you can find volcano tourism in all areas that have volcanoes. Here are some examples of flyers from Iceland. Then there is one from Lassen Volcanic Park in the US. Then I have some flyers here from Indonesia, and also from Hawaii. You can have all sorts of variations on that. So here I picked the Kilauea military camp if you're interested in that kind of thing, or you can have jeep tours, or you can have hiking tours. And therefore there is different attempts to cater for all preferences. And here's this concept that's very important in the Canaries. The local government in the Canary Islands is driving this now for several years. It's called the volcanic experience. So this is a main theme of tourism in the Canary Islands, and this is what I'd like to go through with you today. So where are we? This is the globe, and you can identify Sweden in the top of the globe here, and the Canaries are pretty much in the center of the map here. It's this tiny island group off Western Africa. And if we zoom in a little bit, here's the 7 main islands of the Canaries. And they are a few hundred kilometers off the African coast. And their climate is very similar to Africa, but they have different elevations. And I'll come to this in a few minutes. And therefore, the islands are a little different. Each of the islands has a slightly different character because of also their age and their evolution. And there you can pick and choose depending on what you like best. Visiting the Canaries is a thing that goes back hundreds of years. It's not just a modern phenomenon. This goes back to the 1750s at least. People have been going to the Canaries in order to study the rocks, the culture, the phenomena, and the Canaries were conquered by the Spanish crown in 1470 to 1490 approximately. Some of the eastern islands were taken over by the Spanish crown a little earlier, but there has been European interest and strongholds there for quite some time. And one of the key features initially was that people were extremely interested in finding out how tall Mount Tate is. It was believed that if you climb up there, the sun will burn you. And so people avoided going up there, but they were trying to triangulate its altitude. And this has been the main thing. And here on the right-hand side, there's a Dutch drawing, and you see the little ships in front of it. It was also used as a navigation point when ships were going to the East Indies. Then they would have passed Tenerife, and the tall mountain of Teide was very important there. One of the main kind of changes in the whole kind of situation was Humboldt's visit in 1799. He stopped en route to America and he wrote about Tenerife, and this made Tenerife very famous. A lot of visitors came later on. Darwin tried to kind of go to Tenerife when he passed with the Beagle, but they got refused. It was only a few decades after the Napoleonic Wars, and the Spaniards were not so happy having British ships in their port, so they told the captain of the Beagle that there's a cholera epidemic, although there is no cholera epidemic recorded for that time. So basically they told the Beagle, we don't want you here. But Humboldt was allowed to visit, and he spent 1 week on Tenerife, and he was a workaholic, I guess we would say today. So he used this week for research, and he was really looking at the different plant species and how they relate to altitude. He was describing the cloud phenomena, and here is one of his drawings, and this is of course very important. It made Tenerife popular all over Europe. And at low altitudes, we're growing a lot of crops, and the lower image in the lower left is from the 1950s, and the other images are more modern. Banana production is still going very, very strong in the Canary Islands. So many of the bananas you might have eaten actually come from the Canary Islands. And at low altitude, this is very widespread. At higher altitude, things get different, and Humboldt recognized that. Here's another drawing from Humboldt. He realized that if you change altitude, it's a bit like changing latitude. The further north we go, the colder it gets, and the higher we go, the colder it gets. And this was one of his main realizations there. And this is why we have snow on Teide very frequently. He also measured Teide's height, and he got very close to its actual height, and this made him famous as well. And moreover, he realized that lava actually forms from volcanoes and not underwater, as many scientists believed at the time. So in this 1 week, he had some astounding discoveries, and tremendous amount of work he did in that time. And this really kind of changed the impression of the Canary Islands all over Europe. Now, I'm gonna dive into the geological aspect now. The Canary Islands, they are not standard ocean floor volcanoes. They are actually cutting across the ocean floor anomalies. And here you see the ocean floor anomalies being marked in red. This is what happens when new ocean floor is created at the mid-ocean ridges, and they are really different to that. So this makes them very, very special. They stick out like Hawaii, and very often in geology terms, they are referred to as the European Hawaii. And there are a series of large volcanic edifices, and Tenerife is the highest mountain of Spain with 3,718 meters. And as I said, I worked in the Canary Islands for well over 20 years now, and I've visited all the islands. It's one of my favorite places. I was actually supposed to go there next week, but due to Corona, I had to cancel my trip, which I find a little sad. But I hope to be able to go back there next year for more work. So the islands are of different age, I mentioned it earlier, and the oldest islands are in the eastern part, and the youngest islands are in the west. And this is a concept that is best explained by the plume hypothesis. They're not really a cluster, they're more of a chain. The oldest eruptive materials in Fuerteventura is 20 million years old, while on El Hierro it's only 1.1 million years old. And we also see that there is a curvature that is mimicked by other provinces like the Matera archipelago. So we believe that there is a plate that moves over stationary hotspots, as we call it, or plumes, and these are mantle anomalies. It's a bit like a Bunsen burner underneath a moving plate, and it burns holes into the plate where volcanoes happen to form above. And here is some work I did. You can calculate the rotation of the plate, and you can look at the curvature, and this all makes sense because these archipelagos seem to follow a similar trend. And this is also the concept that is widely used to explain the Hawaiian Islands. And here's some geophysics. Up here, there is the Canary Islands in the top right, and you see these red and yellow colors. There's a mantle anomaly. The volcanoes of the Canaries are fed from deep within the earth, and they're not the standard mid-ocean ridge type phenomena, and that makes them also geochemically and geophysically very, very special. So, and because of the different ages, we also find that they have different erosional patterns. What we find is that they are more strongly eroded in the east. The older islands are flattened, and the young islands are very steep. And the islands in their maximum stage of evolution are the central islands, Tenerife and Gran Canaria. So the young islands are very much to the west and the old islands to the east. And therefore, the old islands are more desert-like, while the younger islands are more mountainous. On the right-hand side, I have some earthquake maps, and here I have a triple junctions, the Azores triple junctions in the middle part, and here we have huge amounts of earthquakes. We also have huge amounts of earthquakes in the Atlas, if that's the mountain chain in northern Africa, in the lower panel on the right-hand side, but we don't see that in the Canaries. So this means it's not a standard plate tectonic fault or so, that these are really different. These volcanoes are coming from burning through the plate rather than coming up along fault lines. At least that's our best understanding at the moment. So that makes them very special. And this is why they're geologically particularly interesting. And here's the concept. This is a Spanish slide from one of my Spanish colleagues. And here we have a hot spot where magma ascent is most dominant, and the plate is moving above this. So we have a stationary hotspot or plume, and that gives rise to these volcanoes growing up. And indeed, what we see is that the islands in the west, they are the smallest and the youngest, and the older islands and the more extensive ones, they are more to the east of the archipelago. So now, what's very special about them? Well, many of the islands actually have historical volcanic activity, and that makes the islands particularly exciting. In the little maps in the lower part of the slide here, the red is the active or the historical eruptions, and we have historical eruptions on Lanzarote, Tenerife, and La Palma. There is some eruptions that we would call recent, i.e. they were in the last few thousand years, and that is El Hierro and Gran Canaria. And then there's two islands, La Gomera and Fuerteventura, that didn't have eruptions in many tens of thousands of years. That doesn't mean they can't have eruptions in the future, but we have no record of them. So, and therefore also the islands are a little different. Let me give you a little breakdown here. On the left-hand side, we have a list of all the historical eruptions going back to 1585. And the last eruption, the last surface land eruption was in 1971. On the right-hand side is an image from Tenerife. There is a good record of prehistoric eruptions, meaning prior to the Spanish conquest, but then there's also the historical eruptions in the upper part, marked in red and orange. And there was eruptions in 1492, actually described by Columbus on passing. And then there was eruptions in 1704, 1705, 1706, 1798, and 1909. So one of the most famous eruptions that you might or might not have heard about in the news is the Hoyo Negro eruption of 1949. And it's believed to be linked to a giant landslide. We talk a little bit about that later. And there's the option of part of La Palma collapsing into the sea. And some geologists are very worried because it could cause a mega tsunami. And I'll mention a few more words about that later on. And here we have the southern part of La Palma Island, the most westerly or one of the most westerly ones. And that has had the most frequent eruptive record in the Canary Islands. And that's also consistent with where the plume, the active magma supply is likely at present. And the 1492 eruption, I will not talk very much about it because Columbus, while he was passing the Canary Islands, he was waiting there repairing one of his ships, but while passing Tenerife, he saw an eruption in the hills, and due to radiocarbon dating, it's now been identified that it is the Boca Cangrejo eruption, and here's the vents of that. So we have actually the first witnessed, the first recorded eruption of the Canary Islands by Europeans is actually done by Columbus in 1492. And apparently the sailors were really worried, but Columbus, being originally from Italy, he said, oh, it's the same as on Mount Etna, it's just a volcano. And he calmed his crew down by saying that apparently. So what else is important in the Canaries? Well, we have lava tunnels, quite some spectacular lava tunnels. Some of them are the longest in Europe. And this is something that I will say a few more words about this later. And another intriguing feature the Canaries are famous for is the rift zones. Many of the islands, certainly Tenerife and El Hierro, have this triangular shape. And this is something that geologists are really fascinated by. How come that these islands have these triple junctions? And it's believed that this has to do with the plume, the magma supply, breaking through the plate, and it makes cracks. And the least effort principle would suggest 3 cracks is what you do as a minimum, maybe more, but 3 seems the minimum. And then these cracks might guide magma, and therefore some of the islands seem to have a triangular shape. In the top right there is the map of Tenerife, and in black I have the historical eruptions. And then there is in the center in red, Teide volcano, the centerpiece of Tenerife, and the image in the lower right is of Teide volcano and lavas that have come off Teide volcano. Now let's stick for a minute with this triangular shape. Originally, rift zones were defined on Hawaii, and you see the vents here on the right-hand side. This is the red and yellows. But in Hawaii, they're actually not as well defined as in the Canaries. On El Hierro and Tenerife Island, we have really well-developed triple-armed rift systems, and they are usually the places where most of the eruption happen. And this is something that geologists are absolutely fascinated by. So here is an image, and this is the rift zone, and Teide volcano is in the far distance. It's viewed from Anaga Peninsula. That's the north eastern part, the little red box in the top inset, and viewing all the way towards Teide. And it's a long ridge-like structure, very peculiar. And this is likely based on fractures that have formed in the ocean floor due to magma upwelling, and this guides most of the magma ascent there. Now, intriguingly, what we also have in between these rift zones is landslide scars. And we have this phenomenon that we know from large ocean islands that they actually can collapse. They fall apart if they grow too tall, and this can cause giant landslides. It's quite big in the media, and I was working with National Geographic a little earlier last summer, and we went to La Palma, and this is where potentially a giant landslide might happen in the future, but certainly giant landslides have happened there in the past. And these are very infrequent on a human timescale, so good chance we will actually not witness one. But we had Krakatau volcano collapsing, Anak Krakatau, in December last year, no, 2 years ago, sorry. And this was relatively small, but we see these volcanoes do collapse, and it caused a tsunami. And sadly, over 400 fatalities were resulting from the Anak Krakatau disaster. Now, if we have a big island like La Palma collapsing, then this could actually cause even more disturbance. So here we have a little map of the Hawaiian Islands in the bottom and the Canary Islands, and the Hawaiian Islands have shed a lot of these giant landslides, and the Canaries in the past as well. There's big scars here, like on La Palma and El Hierro, and this is where large giant landslides have probably emanated, and they are matched with debris avalanche deposit, rubble piles in the sea that have been imaged by sonar studies these days. We also have good evidence that this has happened in some of the older islands. This is now one of the eastern islands, Fuerteventura. And there we have the Jandina Peninsula in the south of the island, and it has this curvature. And this is likely an old collapse where part of the island broke off and fell into the sea. And if this happened, you can imagine that would do a big splash and cause a big tsunami. So geologists are just fascinated by these large-scale mega structures and large processes. And of course, from a geohazard point of view, they're also very important. Now, Teide sits in a, oops, let me try to go back. Teide here, Teide volcano, sits in the junction of a rift zone, of a triple-armed rift zone, and it's believed that there was also several large collapses. And Teide is growing in the center of this, and we'll talk a little bit more about this later. On the island of El Hierro, we have this distinct triple-armed system, and there has been likely collapses in all three directions. And one of them, and in the top right hand, I marked it in red and blue, there's a structure, a fault line, a geological fault of one of these landslides that got stuck. It didn't actually go all the way. And there you see me trying to climb up the fault scarp. And there is one of my former students kind of watching over in case I break my leg. And this was moving so fast that we melted the rocks in the fault scarp. This is the lower right-hand image. And this is something geologists are just, well, blown out of their minds when they see things like that, because the imagination of the scale of these processes is just enormous. And here, coming back to 1949 on La Palma, there was a big fracture opening on the crest of the island. And you see that old photograph on the right-hand side here. That's the fracture that opened up, and it offset the island by several meters. And it's believed that this might actually cause a big chunk of the island to break off. And if that happens, here's some modeling. This might actually mean that we create a tsunami, and this tsunami could travel all the way to Florida, and there it would be a big wave in theory. Will this really happen? We don't know, but it could in theory happen, and certainly it happened in the past that large chunks of these islands broke off, so it's not unrealistic. But as I said, these events are very infrequent on human timescales, so chances we might not see one. So I'd like to now go through the islands in more detail, and I'll start in the eastern part, and I start in Fuerteventura, and I'll quickly introduce you to some of the islands, and we'll spend a little more time later then on Lanzarote and on Tenerife. So Fuerteventura, it's not very tall, it's about 800 meters in altitude. It's got a 116,000 people population. Population density is not too high, it's about 70. As you probably know, population density in Sweden is about 25. So it's more densely populated than Sweden, but population density in Germany and the UK is in the 230s to 250. So compared to some other European countries, it's actually sparsely populated. Now, it's got some beautiful beaches, and it's got some African climate. It's very warm there, but it also means that in the center of the island, there are some desert-like areas. The Spanish conquerors have built some castles there already in the 14th and 15th century. And here you see some nice old castle structures being now surrounded by pools. There's some special plants as well. I'm not a botanist, so forgive me if I don't go into details there. But here, there's a plant that's very common in Morocco and the Canary Islands, but not widely distributed elsewhere. So if you're interested in that kind of thing, the Canaries have some special things to offer there as well. Now, here is some panorama views. The interior is rather barren, and this is great for geologists because it means we can see the rocks. But some of the beaches are beautiful there, and intriguingly, the beaches in the eastern part of the islands are very white, while those in the western part, they're mostly black, and that's because we get a lot of sand from the Sahara, and it's partly blown in. So here's some impressions again. And one thing that is causing a bit of a headache is invasive species here. It's not just sand coming from the Sahara. There's also animals that have come over, probably initially as pets, but once released, they have taken over. And here you see some squirrels, and you see my wife admiring the squirrels, although you're not supposed to feed them because they have replaced all the local rodents. They're really aggressive, but actually they're cute to look at. So tourists are really feeding them, and it doesn't help the problem. And this is something the local authorities are really struggling with. So here's some impressions of the sand coming from the Sahara. There's a satellite image from NASA, and you see how the sand is blown over from the Sahara into the Canary Islands. The Canary Islands are the little tiny dots there in almost the center of the image. And here you see some sand cover over basaltic lava here. And because the islands are rather flat, the sand is deposited here, partly covering entire stretches, tens of kilometers of the eastern islands in particular. So the eastern islands, as I said, they're more desert-like, they are almost Sahara-like, and there is some volcanoes that stick out. These are younger than most of the erosional processes, but in terms of climate, they are very similar to the Sahara. Now, the attractive thing is, of course, there's nice beaches, and there's also some spectacular cliffs. And here's the Famara Cliff on Lanzarote. And Lanzarote and Fuerteventura, they're almost connected. The water depth in between the two islands is very shallow, it's only 30 meters. So if the water level was a little lower, they would actually be one single island. So, and here you see a lot of lava piled up, and it makes for a spectacular scenery, very popular with surfers and other water sports enthusiasts. Now, I'd like to move to Gran Canaria. It's one of the central islands, and it's rather large. It's almost 2,000 meters in altitude, so it's got a bit of mountainous terrain in the middle, and it's got over 850,000 people living there. The population density is 545. So comparatively speaking, it's very densely populated compared to, say, the UK or Germany or France, and super densely populated compared to Sweden. There is some landmarks like the Big Faro, the lighthouse in the very south, and it's a tourist magnet. It's got huge amounts of tourists, millions of tourists going there every year. And it's often described as a continent in miniature because you have beaches and culture and nice old cities, but you also have mountainous interiors, almost Grand Canyon-like landscapes, and you have little volcanoes. And the image to the top left is a village that's creeping up a volcano, and this is actually built on ancient archaeological findings. So even the pre-Spanish people were settling in these areas, and probably there was some attractive, it's probably attractive to live on higher ground. And so the Spanish have exploited these settlements as well, and now the village is still growing up the volcano. Rather intriguing to watch. And some of the buildings in the suburbs of the large city in Las Palmas are very colorful, and there's a certain culture. And of course, concrete is the main method of building these days, but it's heavily supplemented with volcanic rock material. So I would say from these houses there, I would expect that about 30 to 40% of the material used for building is actually volcanic rock. So here we have a clear interaction between the volcanic history of the island, the geological history, and the way people build. In the center of the island, we have some spectacular rock formations. Geologists get really excited about these. Here we have these greenish colors, and people speculate whether it's copper deposits or other things. And here tourists make a big stop. There's juice bars there, and there you can exploit this. When I take students there, we spend half a day at these places. There's some springs on top of the mountain. It's very scenic. We don't have to go into the details of how these things form, but this is something that is very much a tourist magnet. And in the center of the island, we have these highlands, and there is the Roque Nublo monolith, which has also been a holy place for the Aboriginal people, the Guanches. They have already worshipped this place, and you can go up there and hike. It's spectacular hiking above the clouds. And here is a close-up of the Roque Nublo monolith, and it's an 80-meter pinnacle standing out, and it's widely visible. And it's a remnant of a former volcano. The volcano has largely decayed, but this piece is still standing. So people flock to it, as you can see here. Hikers love this place. And so there's a lot of outdoor activities people can do, and it's very exciting. There is some volcanoes on, some young volcanoes on Gran Canaria. The youngest eruption that we know of is about 1950 years old. So it's about when our time started to count, this is when this eruption occurred. So here we have the Caldera de Bandama, and this is a satellite image. And today we are growing a lot of wine around this area. And the volcanic fragments, the lapilli, as we call them, the little stones, they're particularly good for growing things on because they have bubbles and they keep moisture. The climate is not very wet, it's not very moist, but the little bubbles in the particles, they keep the moisture, and that allows to grow a lot of things. I'll touch on this a little later. So, and what's very, very exciting to geologists is you have some rare minerals occurring, and amphibole here is a black mineral, usually coming from depth. It's not super rare, but you get them here in very large chunks, and this is something that geologists get really excited about. And there, in certain places, you're allowed to sample them. In other places, it's of course not allowed. But if you find them in good places, you're allowed to take them, making things very exciting. So you have a bit of a treasure hunt there, and this makes some of these things very attractive. Another aspect that's very important on Gran Canaria is archaeology. And this is the interaction of the people with their surrounding that's recorded here. And here we have a large grain store in northern Gran Canaria. It's called Cenubio de Valeron, and this is where people have put grain from rich harvests to store over years, apparently. There's all sorts of legends surrounding this place. I wouldn't believe the legends so much. I think it had a practical use. And there are several of those cave-like structures that are exploited. There's another hill fortress where the Aboriginal people fought one of the last battles with the conquerors, the Spanish conquistadors. And this is Roque de Bentayga. And there's even some ancient cave paintings and carvings there. So here, sorry, here it is. This is Roque de Bentayga, and there's some of these carvings here and painted as well. And they are very, very interesting for anthropology and also, of course, for archaeology. The caves, they were kind of dug into soft volcanic rock, and some of these caves have been lived in for many hundreds of years, and they're still used today. On the right-hand side here, we have a cave restaurant, and I happened to have lunch there once, and it's rather intriguing. But yeah, it's showing that these structures are still in use. So the soft volcanic rock can be exploited and still is exploited to the present day. Here we have some very primitive settlements, and this is some of the housing that was built close to the coast by the Aboriginal people. And the lower images are from a grave site. The upper images are from primitive shelters, and they were often close to the coast because fishing was very attractive. And these things are now on display, and there's some fantastic museums on Gran Canaria. And here we have a brochure from one of these museums where you can see artifacts, and there's of course interpretation centers, and that's very, very kind of interesting for geologists as well as archaeology enthusiasts alike. And here's just another one. Some of these features might be familiar to you. And in the top right, you see the Museo de Canaria in Las Palmas. This is actually where the largest collection of Aboriginal skulls and bones in the entire Canary Islands are kept. And this is, of course, also a treasure for research, not just for people who are visiting. So I'd like to move on to one of the other islands, La Palma. It's a little smaller and it's a little taller. It's a young island. It's 2,400 meters and something tall. And it's got a population of about 80,000 people. And the population density is 116 per square kilometer. So it's less densely populated. And when you go there, you can feel that. It feels a bit kind of, you know, you feel you have breathing space. So the population density is different to most European countries. And there we have an old part of the island and a young part with the young volcanoes. And the young volcanoes you can walk and hike. It's the Ruto de los Volcanes. And there you can actually hike for more than 20 kilometers along volcanic vents. And there's some spectacular craters. And this is something people enjoy immensely. So here we have La Palma Island. The northern part has one of these collapsed structures. A big chunk broke out, and it allows you to look inside the island, while the southern part is the active volcanic area. And you see the pock-marked kind of rift zone. And it continues submarine, as the little map on the right-hand shows. And you can hike all over this ridge, all along its length. And it's very popular. It's one of the highlights of going to La Palma. So here we have a look into the old caldera in the north, the Caldera de Taburiente, which is also a national park. And then we see the southern ridge, and this is in the top right-hand corner, for example. You see in pink the historical eruptions, and this is where most of the historical activity has occurred. There was a big eruption in 1677, and the drawing on the left-hand side is actually a depiction from 1677. And if you look very carefully, you see some people, there's an arrow there, some people being affected. Well, we don't actually have records of people dying in that eruption, but I think the artist wanted to make it very spectacular. So this is an interesting time document, and here you can really kind of walk around these vent sites and have historical documents that describe the eruption, making it all the more exciting, and a lot of tourists enjoy that. The 1949 eruption was quite crucial also geologically speaking, and here's some images on the left-hand side, some photographs from then, and the eruption vents are really on top of the island, and in the lower right-hand side there's one of these craters from that eruption, and there's a tiny person there, which is myself as a scale, so it's quite a big crater. And in the middle bottom image you see that there's the vents, and there's also some hiking path. You see the trails. So the beauty there is you're free to roam around, and this is very, very attractive. And you will pass one of or several of these craters. Here's the Hoyo Negro crater, and this just means the black hole. And this was one of the main craters from 1949. And there you see the volcanic deposits with little impact marks, something geologists get really excited about. And you can really sense the dynamic and the intensity of the eruption there. The last eruption on land in the Canary Islands was in 1971 in Teneguia. I remember I was a really small child, but I still have vivid memories because my parents were excited about this. And we just got a television at that time. So my parents tell me at least, and I saw this eruption, and later I recognized that it was this eruption that I saw as a very small kind of child. And here we have some images from there and some drawings done by geologists and some night images. So this has been big over the news. There's even a stamp in Spain from this eruption, and you can visit the vent site. And here is my nephew now. A few years ago, I took him to the Canary Islands, and we had a look at the vent site there, and he enjoyed this enormously, so much that he's now a geography student. So this was apparently quite inspirational, he tells me. Well, now there's some other aspects, and that is it's not just volcanoes, but some of the volcanic craters close to the shore are used to let water in, and then the water is left to evaporate, and this is to produce salt. And in this case, there's even a Michelin a star restaurant next to the Salina, the salt plantation, and they offer all sorts of types of salt. It's highly attractive. And there you can have well, a very luxurious kind of meal, and you can see how the salt is made. And I personally enjoyed that very much when I was there. Another very important export article is tobacco. Nowadays, tobacco has fallen out of fashion, but Winston Churchill's cigars apparently were from La Palma Island. And here, tobacco needs good fertile soil, and volcanic soil is often very good for that. And tobacco is therefore grown. These days, We're using it mainly for medical purpose, no longer for smoking, but it's got some good qualities also as a fertilizer. So tobacco growth will continue in the future, I believe, even though that the exact use of it has changed with time. A very quick word about La Gomera. I will have only one slide of it. It's got no historical volcanism. Geologically, it's very similar to Gran Canaria, just a whiff younger. So I don't want to go into much detail. It's got some spectacular domes in the center of the island and some beautiful columns, a bit like the Giant's Causeway in Northern Ireland. It's not very densely populated by Canary standards, and it's rather small. It's a bit out of the way. So it is attractive to some tourists, but it doesn't quite get the main tourist attention. But one island that's rather famous and is up and coming, if you will, is El Hierro Island. And El Hierro Island is rather famous for its ecotourism approach. And it's about 1.5 kilometers in altitude. It's got a population of only 11,000 people. Population density is very low. So with about 40 people per square kilometers, it's amongst the lowest in the Canary Islands. It has an interesting way of generating energy. It's pioneered the wind and hydro energy approach. Here, wind energy is used to pump water, seawater up into volcanic craters, and then it's released when there's no wind blowing, just creating energy, either through wind or through hydro energy. And this is apparently able to sustain most of the island's energy demands. So this is really pioneering in this context. And there's an old legend about El Hierro, and it's the legend of the holy tree, the Garaoe. And apparently, when the Spanish conquistadors arrived, they drove the Aboriginal people into the mountains, thinking that they would run out of water up there and would perish there. But the Guanches, the Aboriginal people, they had a little trick up their sleeve. They had this magic tree that was raining water. And what really happened is that the tree was collecting dew from the clouds, and it was sitting on an impermeable soil. So the dew would drip down, but it wouldn't run into the ground. It wouldn't kind of go away. It would collect in potholes. And so the Guanches were able to sustain their culture for much, much longer. Eventually, of course, the Spaniards conquered the entire island, but for quite some time, the Aboriginal people were able to sustain themselves. So there's some interesting features about this island and some interesting legends here as well. And you can visit that site today. Unfortunately, they charge a fee of €2, but I think it's bearable. Here's a geological map. I mentioned it before. Some of the intriguing geology there is this triple armed, this triangular shape, this triple armed rift zone. And we have some large collapses coming off these rift zone. And this is actually one of the tallest cliffs there in the north of the island, with the red colors, in the whole of Europe. It's the El Golfo cliff. And there, a large chunk of the island broke off and fell into the sea. It's probably the youngest large landslide in the Canaries, and the cliff is 1.3 kilometers high. It's spectacular when you're there. And the lower part of the valley, that's where a lot of wine is grown, so it's very attractive. But the cliff is just mind-blowing. It's really awe-inspiring. There now some images from the other side of the island. There's another kind of cliff, and I mentioned the fault line before, the San Andres fault. And this is where we can see how some of these collapses might take place. And there only a chunk of this island side collapsed. The other part is still in place. Also, it slipped, allowing us to see that fault. So it's beautiful for geologists to get insight into these processes. And the third one here is also a collapse scar. It's got this curved boundary or this curved coast, and it's filling up with lava. And some of the most spectacular lava features on the entire island are there, because this is the oldest of the three landslides, and there a lot of lava has been poured into it and partly filled it up again. And it's now contains several protected sites. So here's more impressions of the lava features there. And I should then add that the last eruption in the Canaries was in 2011, 2012, but it was a submarine eruption, and it happened at the southern end of El Hierro, where the little red box is in the top right. And in the left hand of the slide, you see the submarine ridge of El Hierro. The ridge continues submarine, and on this ridge, this is where the eruption happened. So here we have some images from El Hierro 2011, 2012. It's a strange situation because El Hierro was really doing well with the ecotourism approach, but the eruption was, some people argue that it was overmanaged. There's this little village of 500 people, La Restinga, which you see in the top right hand, but it was just 1 year after the big Eyjafjallajökull eruption on Iceland, and the authorities got really scared. And then some of the products that came up or that were floating on the water, they had a composition that sometimes is associated with explosive eruptions. So people there, the authorities got really worried, and they evacuated that village forcefully, with 2,000 military soldiers being brought in to evacuate the village. And this left such a bad reputation that tourism effectively collapsed after this. So here you see some satellite images, the village of La Restinga, and the actual vent. The vent was about 2.5 kilometers offshore, was reasonably far away from the village, but I understand that the authorities had to be careful. On the other side, nothing happened on land, and because of the worry that people had, tourism has not recovered on El Hierro up to the present day, unfortunately. While the 1971 situation on La Palma actually led to increased tourism. So here, there is a little bit of a problem to be discussed. You can actually damage the economy by overreacting. And this is something that we as a society need to think about a little more.